So, um, Nathaniel, have you ever figured out a way to keep the list from jumping around?
No, I haven't looked into that, but that would be so nice.
When you call in a roll call, it's nice for them to be.
Well, does it jump around when you click on the participants list and you see them? Does that move around?
It stays there, but when somebody talks, they move up towards the top.
Oh.
If you go to the chat, I mean, it might not be ideal, but if you go to where you click, like who you're sending a message to, if you click on like the little arrow by everyone, it comes up with a list of everyone in the chat, and I don't think that will jump around.
Okay, I'll try that. This is the June 23rd, right?
Second.
Second, sorry.
23rd Zulu time.
23rd Zulu time. And session for TeamSpeak. No, wait, not TeamSpeak. For Zoom on Tangerine SDR. And my name's Dave, and I've been working on several little projects. Not a huge amount for this project right recently. I'm still doing a bunch of programming on both work and some for, and I'm doing some work for Tapper, but right now I'm not, other than maintaining the web page. I did get Dan's scripts and I plan to get those posted, but I haven't done it yet. Dan, do you want me to wait a minute or go ahead?
Go ahead.
Okay. And so that's it for me. Next on the list, according to the participant list, is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. It's been a good week. One of the main things I have been doing was getting ready for the CEDAR workshop, and let's see if I can send chat to everyone. And I had to prepare a pre-recorded presentation about the Personal Space Weather Station and send it to the CEDAR National Science Foundation Coupling of Energetics and Dynamics of Atmospheric Regions workshop, which I think Veronica could probably tell you about more in a little bit. And the presentation is posted at the link I just sent in the chat if anyone wants to see it. And this week I'm working on reading papers and trying to write another proposal and working with students and, working with Dev to try to get an EDIS receiver set up at here in Scranton in the near future. We also have Juha Virtanen. He will be giving a presentation at the Hamside Telecon, not this Thursday, but Thursday, July 2nd at 3 p.m. Eastern. So that should be a really good presentation that I'd encourage people to come attend. And he'll be talking about ionosondes using GNU radio. Back to net.
Fine business. And I did watch your recorded video already, so it looks nice. I picked that up off the web. Next on the list, we have Scotty, WA2DFI. Go ahead, Scotty.
Okay, very good. Thanks, Dave. And, just a quick question for Nathaniel. Wasn't your presentation already? Was it on Wednesday or is it coming up?
Tomorrow.
It's tomorrow. Okay. Well, very good. So I took a look at it too. It looks very good. I like it. So what's been going on here? Actually, the big news this week is that our ARDC grant for Tangerine was approved last week. So now we have ability to build 25 prototypes instead of just 6. So good news for everyone. There's going to be a lot more hardware floating around here. And I did get the quote back for the magnetometers, for the magnetometer hats. And we're going to go ahead and we're going to build, here's Nathaniel. Where did he go?
He went away. His line dropped.
Okay. Looks like what we're going to do with the hats is we're going to build 50 of them. So there's going to be plenty of hats to go around for everybody to test with. So that's in the works right now. we're getting ready to start the buy of parts and order boards. I just got the quote back today. I also got a note back from the guys at Intel, and they said they're still trying to figure out the answer to my question on the termination of the RAM. So I'm still kind of waiting on that, but it's going to go pretty fast here once I get that answer, because now we got the funding. We've got to go ahead and build lots of boards. So that's the exciting news here. Back to you, Dave.
So, Nathaniel, did you catch any of that?
He's not connected to the audio yet. Okay.
Hello? Okay.
Yes. Hello.
Yeah, I'm connected to my phone again. I already spoke with Scotty earlier this week, and so I'm aware that we got the funding from the ARDC,
Yep.
which is really good.
And he's moving forward on some builds.
Yeah, on the magnetometer.
Yes, that's very good.
Okay, next on the list is Bill.
I'm muted again.
Go ahead, Bill.
Thanks, Dave. Well, been very busy here. I discovered that the Pavel Demon software that runs the Red Pitaya and runs in Pi HPSDR mode will actually run dual channel. So I spent the last several days putting something in that it was going to need anyway, the ability to support multiple channels simultaneously. And so now I've got the simulator working so that it gets 2 channels of data from the Red Pitaya. The simulator then turns it over to the local host in the same format we plan to use for the Tangerine. And then the local host is able to run a snapshotter mode in which it extracts an FFT from each channel and simultaneously records the data in digital RF. So I still have a few little bugs to work out there. I'm using a thing called FFTW. It's a frequently used package. There are some tricky things you got to do for memory management and some things that it does behind the scenes that kind of trip you up. So I've been scrounging through the online discussion boards, finding out some of the finer points of memory management, what has to be done pretty much entirely manually. The system doesn't help you out at all. And FFTW seems to do some things that actually fight your code in a way. And they do that for purposes of efficiency, I guess. So I've been running 2 channels, running 1,048,000 bins, which gives you a bin size of about 0.45 hertz. And it will do that FFT on the Odroid in about 150 milliseconds. So I've got the system set up so that it will collect 1,048,000 samples, whatever the power of 2 is run there, on both of the channels, and then it will set itself to busy long enough to do the FFT. It writes a selection of that around the target frequency out to a disk, so that you can then bring it up and look at it. You can look at it in Excel, or I've shown to collect the data and look at it in MATLAB and produce all kinds of pretty plots. And while it's busy doing all of that for so many milliseconds, it ignores any additional data that comes in. But you know, the amount of data you miss is so minute in comparison to the amount of data you're using for the FFT. So it takes about 23 seconds to collect 1,048,000 samples. And if you're running 2 channels, it takes about 48 seconds. I'm not doing the thing where you take and overlap them and do all of that because it's hard for me to imagine that you're going to be able to see anything that happens much faster than 23 seconds anyway in the ionosphere. I mean, you can run higher sample rates, well, not with the red pitaya, but on the Tangerine, you can run higher sample rates, but, you know, till you run out of capacity on the Odroid. But anyway, we're making good progress with that. I've got a meeting scheduled with the team, which happens to correspond exactly in the time frame of one of the CDAR things I wanted to watch, but I should be able to see most of it. Probably, I expect a lot of that stuff will be available post the meeting to view as a recorded online session anyway. So anyway, that's what we've been doing here. So we're making, so the big things that we wanted to do to make sure we get ready for the eclipse, that is a snapshotter and fire hose mode and ring buffer, are basically proof of concept working. I mean, they've got to be, I've got to go through and, you know, include all the error checking that you would have if you know, when you're giving something to users, and error recovery and all things like that. So the system is a little bit temperamental and brittle now, but it does work when all the stars align properly. So anyway, that's my report. Back to Net.
Quick question, Bill. Are you using the IQ version of the receiver or the HPSDR version?
I don't know how to answer the question, Dave. I don't know.
So in Pavel's code, there's one that looks just like an RTL SDR, and it does what you just said. And then there's a different one that has hyphen HPSDR on the end, which is the radios that Scotty and I worked on in the past. And I was just wondering if it works on one or the other of those. I assume you just use the I and Q.
I think the answer to your question is yes. Whatever the red pitaya, well, I mean, I can show you the code. I mean, the red pitaya presents a buffer of interleaved IQ data. It's interleaved by block. I think it's interleaved by 512 sample blocks or something. Anyway, I figured out what the code is, and then I take that and I convert it to what the Tangerine uses, and then send it out. And I've managed to, you know, I've got the red pitaya spitting out data, then the simulator is taking it and sending it out again. I'm able to get my local area network so busy with all of that, running 2 channels at 48,000 samples per second. Doesn't seem like a lot, but it's enough to knock the flex radio offline sometimes, because the flex radio is dependent upon being able to talk between the hardware and the software running on your computer. You know, play with that a little bit. But anyway, I mean, those are the kinds of things that users are going to have to contend with. If you have a local area network with lots of stuff on it, and you start putting these high demand things on, sometimes some things are going to happen. So I guess we're just going to have to learn as we go.
I have a couple of red pitayas, so, and I know Nathaniel has one at least. So we maybe can test your code.
Yeah.
Yeah, I have multiple red pitayas.
So anyway.
Yeah, we can definitely do that.
On down the list, we have Dan in for XWE.
Thank you, Dave. Hello, everyone. Spent this week doing mostly single board computer stuff, and most of that was with the Raspberry Pi. Redid some scripts. Hold off just a little bit on putting the scripts out there, Dave. I actually rewrote a couple of them, and I'm going to rewrite a couple more. I have commented them so that people can understand exactly what's going on. And I've also kind of cleaned up a few little issues that I had. Right now, there are scripts for GNU Radio with the Osmocom source block. I think I'm going to add the HPSDR source block to that as well, the one that Tom has written. And I'll send that one to you. Also, FLDigi, WSJTX, and Pi HPSDR. I've been working on FreeDV that has a couple of issues that are really bizarre because you have to do kind of a double compile with FreeDV these days. You compile the codec libraries and then you compile a little helper library, and then you go back and use the output of those two to recompile the codec library. It's really a convoluted mess. And I'm not
Well,
sure why David is doing it that way, but God
well,
bless
David
him.
isn't doing. Oh, the other David.
Yes, the other David, yes.
But our David, he wrote some of the original version of that code. If you didn't know
Okay.
that.
I didn't
And
know
then
that.
people kept hacking it, and it was a problem for Dave Whitten, so he stopped working on it.
Yeah, I did actually. I did know that he was one of the kind of the original guys for the Windows version, was he not?
Yes.
Okay. Also, I've been working on WinHPSDR. That has a little bit of an issue that I haven't been able to solve since there is a missing library, and I have to compile the library, install it, and then do the compile of the code after I've done the library installation. Along with all of this, believe it or not, on Friday of last week, a guy came out with a Raspbian image called Ham Pie. And it has almost all of this software on it, plus a whole bunch of other stuff. It's really pretty comprehensive. The only issue I found with it, and I'm not sure it's really an issue, but it uses an older version of Raspbian. It uses the February version, which is probably okay. I don't think that's a giant issue. The good side of it is most of the packages that he has put into it are the absolute latest versions. For example, the WSJTX package is 2.2.1, which I think was just finalized a week or two ago. So everything else, to me, at least from what I've seen, is really up to date.
Okay.
Anyway, that's about it from here. Back to you, Dave.
Okay. Next on the list, we have Dev.
It's me.
Yes.
Hello, good evening, everyone. So from today, the CEDAR workshop has begun, and I have today attended most of the lectures, listened to most of the lectures. Those were pretty comprehensive by many leaders in the field. Also, we are working towards, as Nathaniel said, trying to assemble our N200 kit. Like, we got many equipments delivered, and we will try to assemble those to build towards our personal space weather station, and we are working towards that. And also, we'll begin by applying UHA's code to understand the job sounder data. So we'll start at that point very soon. I think I'll try to assemble.
I hate to interrupt, but your microphone is volume is way low, and there's a lot of noise or disturbance on it. I can't understand what you're saying.
Sorry.
There's something rubbing the microphone or something. There's a lot of background
Is it better now?
Not much, but a little.
Yeah, I had a fan running very close because I didn't have AC in the room, so so it was a fan. So I was trying to say that, okay, we got the equipment for PSWS N200 kits, and we'll try to assemble those at the beginning to try to analyze, apply UHA's job sounder analysis software. So I'll start by trying to apply that in my computer at my place, and very soon we'll try to do that at Nathaniel's place.
Okay.
So that's where we are, I think.
Okay. Well, next on the list, we have Tom. Tom is on the list next. So go ahead.
Tom here? Here? Okay, Tom, KJ6MKI. I'm basically a fly on the wall. I'm watching the Tangerine project with interest. Most of my projects this week are putting up HF antennas for and 6-meter antennas for whisper work and FT8. And it's just a ongoing process here, tweaking equipment. But I'm really trying to figure out what's going on with the Tangerine and get to a point where I can participate in some of those experiments.
Okay. Well, next on the list we have David in 1HAC.
Oh, hello everyone. Nothing to report on Tangerine, but I've been trying to build large wire loop antennas with tent poles this week. As I mentioned last time, I think we're trying to deploy them to northern Canada, Baffin Island. So been having fun with camping equipment.
What size antennas are you building?
About 10-foot diameter.
Okay,
That's
and
what,
these are loops above the ground?
big
or,
loop, yeah.
Yeah.
12 gauge wire, 10 foot. Well, normally it's a square 10 foot on a side. That's what we've used for our VLF through HF
Okay,
work.
and how are you matching these?
It uses the preamp that I have sent schematics around for. It basically runs into something on the order of 30 ohm load.
Okay.
And that with its inductance makes it flat pretty much from what we, for our design is 100 kilohertz to 4 megahertz or so.
4 megahertz, okay.
Yep.
Okay, great.
Okay, and let's see. After Dave, Holman. Go ahead, Holman.
Hey, good evening. How are you? So slow, but I'm making progress. Mainly thanks to Dave Witten, who provided magnetometer prototype. So I've been playing with it, and it's working from my end. So that was a big progress. And then my next step is to have it installed at Jenny-Jump Observatory, where NGIT instruments are located, so that we can compare the data from that magnetometer with the full-blown science magnetometer that we already have there. Eventually, I have access to that observatory after some, lockdown situation. I guess I think I can go there now to have it installed, sort of quasi-semi permanently, so we can have some long-term data sets. Right now, Dave Witten is working on software so that files can be stored properly the way we usually do as a scientist. Like right now, the data is being written in one single file, which we don't want. We want data files to be saved in the system on a daily basis, so that we have, say, 365 files per year or something like that, each containing 24-hour data files. So that's what he's working on. I think once that's done, then we are ready to go. Meanwhile, I'm preparing for, like, trash can or insulation, stuff like that, something I can get very easily from Home Depot, and going to have it installed. So that's where I'm in right now. The other thing is that, so we are, CEDAR meeting is going on right now this week, as Nathaniel mentioned. GEM meeting, where I'm mostly involved with. GEM focuses more on, so CEDAR workshop focuses primarily on ionosphere and atmosphere, whereas GEM workshop is more focused on a little bit farther from the Earth, like magnetosphere, and how, and try to understand how magnetosphere is connected to ionosphere or solar wind. I'm actually involved. I'm one of the advisory board member for ground-based magnetometers for scientific studies, and hopefully, if we can get a sufficient data set, hopefully you know, I'm going to present the initial result there so that we can let them know what's really going on from our side, Daisy. So that would be pretty good in terms of visibility to let the scientific community know that what we're doing in terms of my metometer project. So that's where I am right now.
Very good. I know Dave is working on that code. So anyway, next on the list is Michael. Go ahead.
Greetings to everyone. I was virtual attending the CDAR workshop this afternoon and found it very fascinating. I wasn't able to do the morning session because I had to take my wife to the doctor about 50 miles away. So I didn't miss out the morning, but the afternoon session was excellent.
Good. Then next on the list is, oh, Terry Bullitt. You want to make any comments?
W0ASP. No, I'm just here listening, so no traffic. Back to net.
Okay. And then next is Tom McDermott. Go ahead, Tom.
Well, good evening, Dave and everyone. I've been playing with my cross loop receiver antenna. I calmed down the gain of the preamp a bit and got rid of most of the AM broadcast overload. Tuned up the notch and took out one of the strong offending stations. With that, I'm able to, this afternoon, I was able to get a side null of about 34 dB down from the front. So it was getting real good front to side on one of the antennas. And I've been listening to some of the aircraft beacons down in the 300 to 400 kilohertz range. Did something happen here? And so it seems to be working. I can see carriers down in the sub 100.
So Dan, it's you sharing your screen. Tom, I can still hear you.
I can't hear him. Nice DC3 though.
Tom is talking but muted.
See if I can help. Tom, go ahead.
Okay.
You're back.
Can you hear me now?
Yes.
Did you hear anything I said previously?
I got to the point where you said, oh, what's going on here?
Okay. This is something strange with the computer tonight, I guess. Any rate, so I've been listening for low frequency beacons and up on 20 meters with the loop. It has good front to side. Interestingly, taking down and nulling out the AM stations does not get rid of the intermod. And the intermod level, in fact, doesn't even change by a single dB. So I have a feeling that those intermods are in fact generated by the AM transmitters rather than in the antenna or the receiver. Otherwise, I would get some variation in those levels. So I think we've got something. Anyway, that's it for me.
Okay. And let me see. I did Tom. Oh, Veronica. Sorry, but being a V, your name went to the bottom.
No problem. It happens a lot. Hello, everyone. This week, much like I also went to the CDAR workshop today, the student workshop, and I learned a lot of interesting things. I found the geomagnetic storms particularly interesting. And then beyond that, I have just been working on learning more about analyzing data with Python.
Very good. I did want to mention, I posted something on the Tangerine SDR list and it's the program. We have all these meetings this week, but the end of the week, the SDR Academy in Germany, which will have Michael, who was on one of Nathaniel's talks, but he's kind of the coordinator for that group, and they're going to have their meeting, which usually is at the Friedrichshafen Hamvention, which is kind of the European equivalent of Dayton, and his meeting will be this coming weekend. I know it's field day, so you might want to look at it later in the recordings. But I put a list of all the talks, and one of the talks is Shell from northern Norway, who worked with us on the Open HPSDR project. So that's it, and we're open for general discussion.
I wanted to ask Tom, are the AM stations that are giving you trouble all in one site or close together? You're muted.
Unmute.
There you go.
I have no idea what's going on here. You used to be able to hit the space bar to unmute, and that's suddenly not working. I've got
Depends
one
on which
AM,
frame you're in.
I've got one AM tower just under a mile away with 3 20 kilowatt transmitters triplexed onto one tower. And then I've got another tower about 1.2 miles away that's got a couple of other high power stations on it. And so it's interesting, I can listen down to 140 kilohertz and hear two of them mixing and putting out a signal. And it's the two stations that are 140K apart that are on the same tower. So I have a feeling that there's some Class C action going on in their transmitters.
Yeah, I'm sure there is. Yeah, we've got a local hill that has high power FM transmitters on it, and they create a tremendous amount of intermod. And they're on separate towers.
Well, and Tom's in the middle of a fairly deep valley with high mountains all around it.
Yeah, it doesn't seem to hurt. I've been listening to the airport beacons, and there's one about 50 miles away that's running 50 watts at 404 kilohertz, and it's about 12 dB out of the noise with the antenna sitting on the lawn. So I don't know if that's good or bad. There's the Siskiyou Mountains are between me and it, so there's a high range of mountains, but I'm getting it on ground wave quite strong.
Where are you, Tom?
I'm in Medford, Oregon. It's just north of the California border, and I'm here in the beacons in Northern California.
Oh, okay. I'm interested that you still have beacons out there in the U.S. Out here, they were signed over to other entities, and they've been left to go derelict. So the beacons I hear over here are all up in Canada.
The one at our local airport, which is about 6 miles away, is like 35 dB out of the noise. It's super strong. Of course, they all identify with Morse code.
Right. Well, I find it's really nice that they modulate with different frequencies, so you can go single sideband and find them easily.
Yeah, old airways beacons, like the 404 kilohertz beacon, runs at 50 watts. The local beacons run about between 5 and 8 watts.
Now, what's the design lower end for the personal weather, space weather station? It isn't going to include these, right? We need to design a separate board to get the VLF stations.
Well, I think we're going to have to characterize the receiver. Currently, I'm using the Hermes receiver, and I can see the noise peaking down at 30 or 40 kilohertz before it falls off to, the noise floor goes down to the bottom of the spectrum analyzer. And the front end we have on Tangerine is similar to that. So I don't know how far down it's going to go. And I also don't know how badly the noise floor degrades down below 300 or 400 kilohertz. So I'm hearing stuff down there, but I don't have a calibrated reference to, say whether that's good or bad. We're going to just need to characterize the Tangerine and see, how good is it, how bad is it, and then we'll, I'm sure it won't be as good as something purposely designed down there, but it may be good enough.
Right. Because I've always thought it would be good to have a distributed receiver system for those beacons as much as they continue to exist. The other thing is 100 kilohertz. If they ever put the Loran system back together, we would probably want to watch that.
Yeah, I haven't put the antenna out on the lawn at night in its current configuration. I'd like to see if I can see 60 kilohertz. I can see stuff at 67 and at 75. I can see carriers there, but I don't know what they are.
Right.
Tom, do you have equipment to characterize the receiver when we get them built?
I don't have signal generators or that are calibrated down there, so I'm going to have to figure something out.
Okay. Because I think I'm going to try to get the DE finished up in the next 2 weeks, and I've got the CAD guys already started on the DE as far as getting a read in, getting the parts built, and all that. So it should go pretty quick once we get the final questions answered. And then once we get the layout done for the data engine, I think we can proceed with building the RF boards, because once we know they physically are not going to have to be modified to plug into the DE, we should go ahead and build those and get them out of the way. And now that we got the funding, we can go ahead and build 25 of them, which is going to be kind of interesting. We'll have plenty of hardware.
Okay.
Do you have the ability to? No, go ahead, Tom.
Oh, I'm sorry. I didn't mean to. You can't tell when I'm muted or not. Go ahead. Why don't you go ahead, Bill?
Do you have a simulator that allows you to start developing the FPGA code where you can develop the code and run on a simulator and sort of test it in a sort of a software environment? Does that exist?
Yes. And what I've been doing actually is I've been building up the basic building blocks of the code itself, because you have to make sure that the FPGA is pretty particular about some I/O pins. So not all I/O pins are created equal. They can't be swapped at will. And so the idea is that when you design the hardware, you draw the schematic, and then what Altera wants you to do, or Intel wants you to do, is build an FPGA project and make all the connections the way they are on the schematic to verify that it's going to work right. And because the I/O signals are divided into different banks that can have different I/O voltages, and some banks are faster than other banks because of the capacitive loading effects, especially when you get the big 672 pin package. The timing is different because the capacitance of the pins on the part is larger because the part is physically larger. So what they suggest you do, and this is how I found part of the problem with the memory, is I actually went ahead and implemented the memory before I had any hardware at all. And then I try to compile it, and I see what the tool says my timing is. My timing, whether I meet timing or not, and I don't. So then I say, okay, now wait a minute, this says it's not going to work when we get the real board. So I got to go back to Intel and say, hey, do I really need this speed graded part? And oh, by the way, we can't get the -6 high speed grade part, fast speed grade part, but the tool doesn't have the calibration files for that speed grade part. So this is what I'm waiting for from Altera, is to get the proper, it's a patch to their code that allows you to specify the -6 speed grade and get real timing. So once we get that and we take the design that I already have and compile it and see that it actually meets timing, then we can be reasonably well assured that it's going to work on the real board when we get the real board. But but even that's only one subsystem. So what I'll do is I'll take the inputs from the A to Ds, I'll hook them up to the exact pins that we're going to use on the after we get the board laid out that match the schematic, and then I'll run a fur filter. I'll just put a dummy filter in. It doesn't really matter what the cutoff is or anything. It just matters that you put some cells in that somewhat resemble what the final is going to be. And then we compile it and we see if it runs, see if it compiles. And this is even, I think, maybe a little bit prior to the question you asked, because you're asking if we can simulate it. Yes, we can, but even before that, we can determine whether it's going to compile into the device first.
Yeah.
And so if we find it doesn't compile into the device, we might have to move some pins around, or we might have to, so we have to make sure that we do that before we commit to any copper on the board.
Yeah. I'm probably getting a little bit ahead of myself, or a little bit ahead of the project. I'm just starting to think about the next steps of verifying it's possible to achieve the interface that I've kind of tentatively designed, as far as how the local host and the data engine talk back and forth to each other. But we'll get to that when we get to it.
So one of the things that's really nice about the FPGAs is, until you run out of space anyway, you can put diagnostic modes in. So for instance, instead of having a full-blown receiver where you have to have an RF board and it has to all work and everything is all debugged, we can just substitute an oscillator in place of an input signal and say, okay, let me give you the maximum value of input signal that like all ones coming from the ADC, sine wave with all ones from minimum to maximum amplitude. So, and this will be the largest single signal you'll ever receive. Now, it doesn't really characterize how the whole system works because it's only one tone, but at least it gives you something to decode, something to feed your FFT, if you will.
Yeah. I mean, I'm doing that in software on the simulator, but I'm anxious to, verify that the tentative protocol design makes sense. That if we need to change it, it's better or sooner than later, because I have to change things in software. So
and so we can get an idea of what will fit and what will meet timing before we have any hardware. So once the board is off and being built, then theoretically I should have pretty much the framework of the whole FPGA code in place, because I did it in parallel.
I can tell you learned something from HPSDR.
Oh yeah. I'm going to borrow a lot from HPSDR.
Yes.
Whatever I can borrow, I'll borrow. But so it's going to be interesting to see. I mean, it's a Max 10. It's not a Cyclone 5, so it's different.
That's right.
Although, well, I just got a call from my rep today, and he's asking me about volumes. What's your volume going to be? Because he's concerned. Because I really beat him up for the price on the part. I said, look, if for this entry level one, for the Max 10 one, we got to have a cheap price, because we're competing against Red Pitaya, and we're competing against everybody else who's got a low end SDR. When you go to the Cyclone 5, I said, I'm not going to be so critical on beating you up for the price, because the board's already going to be expensive. So what's another few bucks there? But another few bucks here might mean the difference between people buying it and not. So we want to keep it as cheap as possible. And he didn't quite get it down to where I wanted, but he got it close enough, I think, that we're going to be able to do it. It's basically the Cyclone 5 is pretty much going to double the cost of the board. So it's definitely going to be, for the people who really want lots of computing, that's the board that they're going to want. But this Max 10 board is no slouch. It's going to have 50,000 LEs. So and we're getting the highest speed and the widest temperature range part that they make.
Yeah.
So which is why it's expensive. In fact, I'm looking at it, I'm astounded that he can give us the price that he does, but I'll take it.
What is the price, Scotty?
Pardon me?
What's the price?
I'm not sure I want to put this out on a public forum, but I'll be happy to tell you in private.
Sounds good.
Because we negotiated special, and I'm not really supposed to say, because we're an Altera partner, so it's and it may make some non-partners a little bit irritated because it's pretty inexpensive, I think, compared to what if you just go out to DigiKey and you go just buy one off the shelf, it's very expensive. So it would be it'd be prohibitive for us. I mean, there'd be no way we could make the station. We could get in under $500 for the RF board and the data engine.
But the part that you're talking about something that goes in the data engine?
Right. The FPGA for the data engine.
Okay, I thought so. Just making sure.
Incidentally, it turns out that I think we're going to have to really try hard on this, but the RF board is coming in higher priced than the data engine, the BOM cost, because of the ADDs. And, it's the precision. I mean, it's what's going to determine your performance. So but we're going to try to get the parts as cheap as we can. The problem is that I'm not an analog devices partner or anything, so I don't have any special privileges there. I don't have any magic negotiating there. Anybody else who does can help us. But Nona, who is our parts buyer at where I work, and now she's retired, so she's going to help us out for just because she's a nice person. She's really good at squeezing the parts out. You're not going to believe it. Some of the parts we use on the magnetometer board, they're just like a SOT23 5-pin gate. Okay, I mean that's like 20-30 cents, right? She found them for 0.01 cents, and I'm not making not a typo. It's like it's free. It's almost free. I said, well, why don't you just buy a reel for that price? I mean, it's going to cost you $5 for a whole reel. But I don't know why. It's like at Newark, maybe she found this. She found that they have a surplus of them or something. They're trying to get rid of them, so they mark them down. And
Well, the downside of having a surplus of something sometimes is that means it's about to be discontinued, and then good luck trying to repair things or get replacements or build the boards 2 years from now.
Yeah, but I think that this part has multiple pin compatible replacements, so I'm hoping that that's not the case. And go ahead. On the magnetometer, it's just for the interrupts that are not used right now anyway. So if they did become unavailable, it would be not that big a deal. But yeah, you're right. It's usually a warning when you see stuff like giveaway prices. It's like, well, that's because we're not going to order any more ever. Yeah. But I thought for sure when I saw it on the BOM, it was a typo. Oh, well, you got the decimal point in the wrong place, right? That's really like 10 cents, not a tenth of a cent or a hundredth of a cent. It's amazing. Anyway, she's really good at scrounging cheap prices. So, and we actually found for the Raspberry Pi header, that has the long pins, so you can stack the boards. There is a place in the UK that specializes in making it. They I don't know how they do it. It's a Samtec connector, but if I go to Samtec and try to buy it, it's like $2. If I go to this guy and buy it, it's like 70 cents. I don't know, and he's got his own part number, so he must buy like millions of them from Samtec and then resell them. That's the only thing I can figure. It's a standard Pi hat connector. I mean, I don't see why it should cost so much, but I'll pay 67 cents instead of $2. No problem. I'll order from him. Of course, you have to order more than 3 or 4 because then the postage starts getting you. And that's That's what she does. She figures out what's the best way to do it. What's the best way to order. It's also interesting, buying for prototypes is different than buying for production, because you've got to buy extras for prototyping, because if they're going to put them in a machine for automated assembly, you have to have a leader on the beginning of the reel.
Yes.
And it costs money for them to tape a leader onto a reel. So it's a trade-off. And I tell you, one of these parts that we have on the, Tom, you put the, that surge suppressor on the front end. Remember that GBL03C? Did you put that on for the ESD protection like we did on the Hermes board?
Yeah, it's up there. It's a 3-volt peak-to-peak clamper diode, and it's to keep any large transients out of that A to D converter chip.
Right. It's also only available in reels.
Okay.
But that's okay, because we have a secret source that we can get partial reels from. So I mean,
there's capacitors to block DC, but you know, when that capacitor decides to dump its charge, it can easily blow up an IC.
Yeah. So this is to protect the amplifier, right? Or the
it's to protect the front end, that front end chip.
And I find it interesting, when we did the Hermes board, remember Phil Covington did his SRL? Do you have SRL? Software Research Labs. Anyway, he built a version of the Mercury board that did not have an amplifier before the ADC. And I was at FDIM, and there were guys telling me that they actually burned out the ADC on their board because they didn't have protection. And I think on the Hermes board anyway, I think on the Mercury too, we use the same part. So it takes care of a lot of evils. Oh, you're muted, Tom.
Sorry about that. I don't know why my mute is backwards tonight. You don't want to use the clamp diodes in the ICs to limit the peak-to-peak input, because they can't take much current.
And then when they go, then the whole input goes, and then you're soldering again.
Just a thought, what do those protection diodes do to your input impedance? How do they compromise a high impedance input?
They are special low capacitance diodes, and they're sitting at a 50 ohm circuit point. And so I think the capacitance is just on the order of a puff or so, maybe 2 puff. And so they, with 50 ohms impedance, they're not
a problem
too much. You know, you're worried, of course, that you get intermod, and so the diode is it's a 3-something volt sharp cut diode, so it, for normal signal levels, it shouldn't be an issue.
What's it called? Is there a number for it, or?
Yeah, it's a GLBC03.
Somebody was interfering. Could you say it again, please?
It's a GLBC03.
GLBC03.
Yeah, I'll have to pull up the parts list here to get the manufacturer.
We have Terry with his hand up. Terry, do you have a question?
Yeah, in fact, I do. That's why I raised my hand. I had a question about your A to D converter. Does it have an overflow bit, and is that overflow bit fed to the data engine?
Yes, yes, and yes. Both channels have overflow bits, and they're supposed to be sample aligned on overflow, so those go into the bus that goes over to the FPGA.
Are you going to latch it?
The part, right now, we don't process it. The part puts it out, and it will be up to the FPGA to decide where it goes. We didn't want to do anything that would lose the correlation between that bit and the sample that it identifies.
Okay, well, because that bit can overflow very rapidly. And it can actually, if you're doing any Fourier processing, it totally destroys the entire FFT sequence that you're making.
Yes, so we capture that bit along with the 14 bits of data. So really we get 15 bits that we clock in, because it's valid every sample. So it's updated every clock. So we have to grab it every clock also. And then that allows us to either we can either max pause or min neg the output when we see an overflow, or like you said, we'll have to lash it so that the software it'll be there long enough for the software to read it.
Okay, that was my question. Thank you.
I'm not finding that part number. Can you bring up a link?
Okay, hang on. I'm trying to take notes.
Here, I can do it, Tom, if you.
Okay.
Yeah, that part I have a semi-dyslexic reaction to because it's got too many L's and B's and C's all in a row. So, let's see, I got the data sheets here on the computer right here. As soon as I find the directory.
I've always used biased hotkeys for protection. I'm interested in what this one is.
Oh, that's not it. Okay. Let's see, we got it on.
Okay, I've got the data sheet up. It is from a company called Protek Devices, P-R-O-T-E-K, and it's called an ultra-low capacitance device. Part number is GBLC03, and it's the bidirectional device. So that puts a modifier on it. Let me see. It's GBLC03C. It's rated at 3.3 volts standoff voltage. Minimum breakdown is 4 volts. Minimum clamping voltage is 7 volts. Typical capacitance is 3 puff.
Could you post that in the chat room, please?
Okay, I don't know. I got the data sheet from arrow.com. I have the doc. I don't know if
you Google it, it'll come up under the Protek website.
Okay, so yeah, let me put something in the chat.
They have a data sheet that covers GBLC 03 through the 24C. Presumably that's the voltage breakdown.
Yeah, that the 3 stands for 3.3 volts rated standoff.
Yeah. Huh. Yeah, it's exactly what I was thinking it would be, is a Schottky diode with a Zener in series.
Yeah, and the bidirectional one's got a pair of them anti to each other.
Right.
So considering it's only 3 puff, it has minimal impact to the system.
I think that's the link to it, Tom.
Thank you, Scotty. I appreciate it.
Yep, that's it.
Okay.
Excellent.
Good.
Yeah, and the one we use is the bidirectional one, right? So it's got basically the avalanche diode in series with the standard diode and 2 of them back to back, 2 pairs back to back.
Correct.
Yes, that's the one. It's 2 pairs back to back. So the receiver's got AC coupling capacitor on the input, so you can put a DC bias source out to an active antenna and not have the DC get into the receiver. But you have to be careful because you can store a lot of energy in a 0.1 coupling cap, and so you have to be careful.
I'm amazed that these things get rated 350 watts peak pulse power.
Yeah, for 8 nanoseconds or something.
Yeah.
Where's the joules is what's really important.
Yeah, that's it. But we had a job one time where we had to build a controller for a Stirling engine solar catcher. It was called a sun catcher. And so these were out in the field and they ran big like double-aught cable from every unit back to a central location where they aggregated the power and stepped it up to line voltage and all that. And they wanted us on our board to handle a load dump that would happen in case we were at full power output in the breaker trips in the aggregation shack. And it was one of these things where they just, kind of on the fly just added it to the spec, Well, we calculated what the load dump would be. and you need a TVS like the size of a garbage can to absorb the amount of energy that occurs when the breaker trips. So we had to go back and renegotiate that point with them so that they had to handle it a different way because there's no way we could handle it on our board. But it was easy for them to spec it,
They had the decimal point a little off.
Yeah.
It's so easy to specify things that somebody else has to do.
That's right. So I don't see anywhere on here where they have the joules required.
They don't.
It does? Does it say anywhere?
No, what they do show is the pulse waveform. It's about an 8 microsecond pulse. That's right.
Oh, there. Okay, I see that. Yeah. So you could calculate it then, but don't do that to your poor receiver. Don't transmit into it.
Yeah, I don't think that clamp diode's going to help you much if you transmit it.
Yeah. So Tom, on your intermod, do you think it's a product of it's an actual real product of the two transmitters?
Yeah, I think so, because I can turn the antenna and take down some of the AM stations down, better than 30 dB from the front. And so the front to side, it's hard to measure better than 30 dB because the notch is extremely narrow. And, you go out and you move the antenna a 1/4 inch and it changes. But even moving one of the strong stations down 30 dB, the intermod products don't move even 1 dB. And so that's not any characteristic of a receiver front end. That's a characteristic of the intermod being generated in the external environment somewhere else. Chain link fence, triplexer on the tower. I've listened with a passive antenna and a good communications grade receiver and found intermod products from the two stations up to the 29th intermod product.
Oh my God. And these are like 50 kilowatt stations?
They're about 20 kilowatts, but they're less than a mile away. And so, there's something non-linear in the field, I think, that's doing it.
Have you considered
They're just mixing in the transmitters.
Yeah, I think so. There's a spec, it's my understanding, according to local ham, that the FCC has been called out many times to look at this particular situation, but it's down enough dB to meet their criteria, but it's up enough dB to annoy all the locals.
Yep. Well, we get that kind of intermod like 5 miles away from the FM antenna farm that I was talking about, so not surprised.
Yeah, so it's going to be a real problem, I think, when people deploy the personal space weather station. They're going to have to understand internally generated intermod versus externally generated intermod.
Well, hopefully we can find some quiet sites to put a lot of them. By the way, I calculated it's approximately 3 millijoules that this thing will take when you multiply it out.
Doesn't sound nearly as impressive, though.
No, it doesn't.
Yes, how many amps did it say?
Well, it says 350 watts for essentially 8 microseconds, and that calculates out to about 3 millijoules.
Wow.
Well, we're at about an hour since we started. And I know Nathaniel's in meetings all week here.
So Nathaniel, what is that behind you in your background? Looks like the switchboard at Scranton.
Yeah, that's the switchboard at Scranton. No, that's the ENIAC.
Oh, that's the
Ah,
All right.
Yeah, that's right. I couldn't let Bill have the oldest computing environment behind him, so I had to try and one up him.
Ah,
So they're programming it as we speak, right?
That's right. Yeah,
All those cables.
that's right. Exactly. See if I can bring up. Let's see. I just
now
here
what
it
is
is.
what's the writing on
Here,
the wall behind there?
Here's
Something
the
about
link.
equations in space.
There's the history from IEEE Spectrum.
We're not seeing your screen, or I'm not anyway.
I put it in the
link.
Oh, in the link. Oh, there. Never mind.
I can
Uh-huh.
I can share it too.
Oh, yeah. Okay.
According to the article, the first programming of the first computers was done by invisible women. But you can certainly see them there. They're not invisible.
Invisible women, huh?
it looks like it's all patch cables.
It's interesting they went from being the computers to being the programmers.
Yeah.
Okay, before we go, I got to put up the. I can find it. My QRP station. I can find it. That's the trouble with terabyte hard drives.
You can't find anything.
Yeah, you can lose things very easily. I've got thousands of files that I don't know where anything is. David, N1HAC, what is that tartan behind you? Is that some kind of a family color or something? Or?
Yeah, that's the McFarland tartan. My family comes under the McFarland clan.
And I see some ribbons on the corner. Did
Yeah,
you get
well,
a prize?
Those are for participation in Highland Games.
Oh, okay.
Over the years, and we had a virtual Highland Games over the weekend, so I put that up.
Oh, very
and I haven't
good.
taken it down.
I suppose you threw the virtual caber?
I didn't.
Well, if it's virtual, anyway.
Yeah. I'm not inclined to throw telephone poles.
Okay.
Yeah, we went to the Stone Mountain Highland Games near Atlanta last year. That was very much fun.
That's one of the big ones.
We had. It was just fortunate that I had a heavy kilt all made out of wool because it was cold and rainy, and the organizers thanked all the participants for bringing along genuine Scottish weather.
Yes. Well, in New England here, we don't have to even order it up. It just is.
Yeah, right.
So
you don't like the weather? Wait 5 minutes.
Scotty, what is this?
This is a QRP transmitter from. Now, unfortunately, on this computer, I don't have PowerPoint loaded, which is that has all the information about this slide. But it's an RCA 50B transmitter. I think it's 50,000 watts, and it's from like the 1920s or 1930s. So you can kind of see the genre. I like the operating desk. You know, it's sitting out in the middle by himself, and if you can see behind the desk, there's a whole bunch of connections that run into the floor below the desk, between the desk and the floor. So, but I don't see any control box. I mean, there's one box on the desk and a phone, and it looks like a pad of paper. What does the guy do? Does he sit there and wait for sparks or something? What? How does he operate the transmitter? Don't know.
Maybe that box just has a telegraph key in it.
That's right. But I was giving a talk at FDIM at the QRP meet at Hamvention. So I put this slide up to explain why I'm not really a QRPer. I had to have the one gratuitous non-QRP slide, you know, in the deck. So anyway, that is all. And you know, it's one of those things when you're making a presentation and you're looking around on the net for certain pictures and something like that pops up, or something like Nathaniel's background, you just can't not use it. You know, you got to figure out a way. It's so cool. You have to figure out a way to include it in your presentation.
That's kind of like Phil Harmon with his big horns.
Yeah.
He had a talk where he had World War I artillery horns that people would wear to hear the artillery coming in. And
yeah.
So it's like a gramophone horn stuck in your ear, right?
Yeah,
basically,
but these things were huge.
One.
They were on a cart, and then you'd stick the bottom end of it into your ear.
And then they would use them to listen for bombers coming in.
Yeah.
On the note of QRP transmitters, I've been trying to find information about one that's at, used to be called Sonderstrom, now Kangerlussuaq in Greenland. It's actually a generator that was hooked up to the VLF antenna system. But I haven't been able to find anything online about what that transmitter was.
You mean a mechanical generator like an Alexanderson alternator?
Exactly.
Okay.
And the generator's still there.
Really?
Yeah.
How about the antennas?
The antennas have been dismantled, but the generator was so big they never took it away.
Size of a container, right?
Mm-hmm.
Or bigger?
Well, it's a huge diesel generator with, equally large generator on it. It was a VLF transmitter, I think through World War II, but I haven't been able to find information on it. I knew I had searched on it some years ago, and whatever the source was, it's disappeared.
You're going to have to go there and visit, write the story yourself.
I'm going to go QRT here. I'm running down, but.
Well, I used to visit there every year, except they dismantled the ionospheric research facility there.
So long,
See you,
Bill.
Good night.
7-3, Bill. Hey, before you go, how's your wife doing? Oh, you're muted. You're muted, Bill.
There you go.
She's on the mend. She felt good enough to take the dogs to the dog park, so that's
good.
That's a big step for her. I mean, she's got a long road to recover from her bacterial infection in her lungs. It's at another 5 months at least of 3 times a week you have to take a cocktail of drugs to knock it out. But at least seemed like she's turned a corner. But the drugs themselves make her feel rotten. So it's up and down. So, but anyway, progress.
Good. Sounds good. Glad she's doing well.
All right.
Hey, thanks. Good.
Okay.
And we'll talk to you next week.
73.
73.
I've got a dinner call. I'll see you all soon. Thank you. 73 is all.
73.
73.
I got a dinner call too. I got to go get dinner for the cats before they chew my leg off. I fed the last cans of cat food last night, so it's like, uh-oh.
Okay, you better do that.
Too. Good luck with your meeting, and see you guys all next week.
Very good.
Thanks,
later.
7-3 is good luck, Nathaniel.
Thank you, everyone. Have a great night. Bye.